Imagine we were given this as a question, 450 plus 372. First thing we want to be clear on is this symbol in the middle, this add symbol, plus or add, whichever we prefer to use. And we are given this question, 450 plus 372. Now, if I said to you, just thinking about life, if you were to come across this in life, perhaps this is two sums of money that we're adding together, what might you do? What different methods might you use? Well, I would suggest that the first thing you might do is you might pick up a calculator. And if this were a calculator question, it would be nice and simple to just pop the numbers in our calculator, 450, press your add key, 372, and then press equals. Out comes an answer, 1 mark at most. In fact, this would not be a calculator question. They wouldn't bother wasting a mark on a calculator question. However, this is the kind of thing that might come up as a step in a calculator question's working. And as part of that question, you are more than entitled to use your calculator to work out the answer to this question. But let's assume instead that we weren't using a calculator. Let's think about what pen and paper methods we might want to use. So then, if calculator is your first option, your second option might be to use a selection of different methods. Which one of those is the best one to use is completely up to you. You might, for example, try and do a little bit of splitting these numbers up into their different parts. 450, you could take the 400 part of that first of all, and you could take the 300 part of the second number and add those together to get 700. 400, 500, 600, 700. You might then take the 50, that's the tens part of the first number, and the tens part of the second number. 50 plus 70, add those together, well 70, 80, 90, 100, 110, 120, and then you could take the units part of the two numbers, the 0 and the 2, which would just give you 2. Once you've got those, you could then add the three different bits together. Well, 700 plus the 100 is 800, plus the 20, 820, plus the 2, 822. Would be a perfectly reasonable way to do it. You might also start at the other end. You could start with the units and start with the 0 and the 2 and then do the 50 and the 70 for the tens and then do the 400 and the 300 and do it that way and add them up backwards from this way. But either method, splitting the two numbers up into their different parts, would be a perfectly reasonable way of doing it. Problem with this is that you've got 3 additions here and then you've still got to add something up at the end, and you might have, if you had bigger numbers, 4 or 5 or maybe even 6 different things to add up at the end. So it's difficult to say whether this is necessarily quicker, but if this is the way that you think, then feel free to do it this way. Your next option might be to take one of the starting numbers, perhaps the bigger one, although it doesn't really matter. Perhaps we take the bigger one to start with, and then we're going to add on chunks of the other number. We could, for example, add on the 300 part of the next number, 450 plus the 300, and build up to it that way. Well, 450 plus the 300 would be 550, 650, 750. We could now take our 750 and we could try adding on the next part, that's the 70. Well, 750, 60, 70, 80, 90, 100, that's 800, 810, 820. And then we could finally add on to the 820, the 2 at the end there, and get 822. There's a couple of different variations on this. You could add the 2 on first and then the 70 and then the 300. You could always start from the 372, add the 400 and then add the 50. But you could do it in this kind of way. Start from one of them and add the other one in chunks. The final option of the ones that are the most commonly used is probably the most traditional. And much as I am a fan of unusual and odd methods. Actually, there is something in this. And I think the problem with this method is that it's never really explained how and why it works. You know how to do it, and you'll see in a minute that actually probably most of you will know how to do this reasonably well, but you won't necessarily know why it works. So I'm going to really drill down with this method and explain why it works and how it works, so that hopefully, if this is the one you want to use, it might just click a little bit more. And the one we're going to go for is the classic column addition, using the hundreds, tens and units grid to set things out in columns. We could write the hundreds, tens and units column headers across the top if we wanted to help us space things out, whether you do that is personal preference. 450 and 372. Lining them up, 4 and the 3 and the hundreds, because they are the hundreds numbers, and the rest of it following from there. I'm going to finish my columns off. I'm going to give myself a total line, an answer line, and I'm going to give myself the plus symbol in there. That's just a bit of notation. We're going to write it down so that we remember what it is we're doing. Now what we're going to do is we're going to add these columns one at a time. We're going to start in the units, and we're going to have no units and 2 units. And adding those together, well, that's 0 plus the 2 is 2 units. So far, so good. Now then we're going to come to the tens, and we're going to have 5 tens, and we're going to add 7 tens. And at this point, it's important to notice the way I am reading these out. I am not adding 5 and 7. I am adding 5 tens and 7 tens. And that's important. 5 tens, add 7 tens. Because 5 and 7, if I add those together, will give me 12. Now I can't just write 12 in here, because we know from any of these uses of the hundreds, tens, units grid, all the ones we saw about ordering numbers and writing them properly and reading them, we can only have 1 digit per column. And here we've got 2. And if we did allow that, then we'd have the hundreds, and we'd have the 4 plus the 3 is 7, and we'd have 7,122 as an answer. Now we know that's wrong. There's 2 reasons why we know that's wrong. First, because we've seen other methods that have given us the answer 822, so we're expecting that already. Now, if we hadn't done other methods, we might also recognise that this is clearly wrong, because something that's around about 400 and something that's around about 300 should be coming out around about 700, not 7,000. It is clearly far too big. So there's a problem. So we need to do something else with it. Now, most of you can see where this is going, and most of you are already thinking of a word. It's a word that begins with a C. I'm not going to mention it yet. I'm going to come back to it later. To explain what happens here, we're going to notice that it's not a 5 and a 7. It's a 5 tens and a 7 tens. And if, just off to the side, I add up 5 tens and 7 tens, that's 50 and 70. Because remember, of course, that is not a 5 but a 50, and that is not a 7 but a 70. Really, if we think about the place value those numbers have, 5 tens and 7 tens, 50 and 70 would be 120. That's 120. As in, 100 and 2 tens. 120 is 100, a 1 in the hundreds, and 2 tens, a 2 in the tens. And that's what we have to then transfer to our column addition grid. We have to have 2 tens in the tens column, so we have to be able to show those 2 tens somewhere. So there's going to be a 2 in there. And we then have to have a 100 somewhere in there. Now that 100 we've not done anything with yet, but when we add up the hundreds, we're going to have to add up the 400s, and the 300s, and this 100 that we've just gained from adding the tens. So that 100, I am going to write it somewhere on my sum, somewhere in my working out, so that I add it up when I get to the hundreds next. Different options, personal preference. I'm going to put it there at the bottom of the hundreds column. Some people like to write it up here at the top of the hundreds. Some people might like to write it underneath the grid, still in the hundreds. It is completely your choice where you put it, as long as you do the same thing every time, just so that you don't forget. And as long as you remember to do it. Wherever you choose to put it is completely up to you though. I'm going to put it here. And then I'm going to add up the hundreds finally, because I'm going to work up the columns in size order from smallest to largest. So in the hundreds, 400s plus 300s is 700s, plus that extra 100 we've just gained, so that's 800s, and we get 822. Now actually, if we ignore all this and just look at the diagram that is here, you'll notice that we have done this very traditionally. Nothing different has gone on. All I've done is I've explained where this comes from. Now the word that you might have associated with this is the word carrying. I don't really like that word because it doesn't explain what we're doing. Nowhere in this question has anything been carried. All we've done is we've put something in a column. So actually what we're doing, I'm not going to call it carrying, I'm going to call it swapping. Because we have done some swapping. We've swapped 120. We've swapped 12 tens. 5 and 7 is 12. 12 tens. We've swapped a 12 for a 100 and 2 tens. 100 and 2 tens. We've swapped. We haven't carried anything. Although again, the method is exactly the same from what you might have already expected. Now the advantage to using the hundreds, tens and units grid, if we can at all, although again it's not the only way you might want to do it and it's not necessarily the best way for everyone, but the advantage to using it is it's very easy to adapt for much bigger or much smaller numbers. As long as we can line everything up in the grid, the method works exactly the same however big or small the numbers are. For example, if we had a question like this, 12.37 plus 1.05, yes, they're slightly mucky decimals, they don't mean as much to us, it's harder to understand them perhaps, but as long as we can line them up in the hundreds, tens and units grid, then we can add them in exactly the same way. 12.37, in our grid it goes. We can use the decimal points to help us line the numbers up, so there goes the decimal points, 0.5 after, and 1 in front. Finish our grid off, put our plus in there. We've got our total line, we've got our plus, we know what we're doing. We can then add them up in exactly the same way using the same method. We start with the smallest column, the one the furthest to the right. 7 plus 5 is 12. Well, the 2 is going to have to go in there and the 1 is going to have to go in the next column up ready to be dealt with. Because we've added 7 hundredths and 5 hundredths to get 12 hundredths. Do we need to understand what hundredths and tenths are to do this? No, we don't. We just need to recognise that the 12 hundredths will swap for 2 hundredths and 1/10, because that's what we're doing. We're swapping it for one of the next column up in this case. 3 and 0 and 1. 3 tenths plus no tenths is 3 tenths, plus the extra tenth we've just gained from the swap will be 4 tenths. Decimal point goes in because they all line up, so it will be there in the answers as well. 2 and 1 is 3, that's 2 units, and 1 unit is 3 units. And then 1, 10 and no tens will just be 1/10 and a final answer of 13.42. It's often worth a check with these adding questions whether that seems like a sensible answer. So we could just do a quick bit of rounding. It's often worth a check with these kind of questions whether our answer is sensible. So we could just do a quick bit of roughing it. 12.37 plus 1.05, well 12.37, roughly 12, 1.05, 1 pretty much. 12 plus 1 is 13. Our answer is about the kind of size we expected. It's a little bit more than 13. That seems like a sensible answer. A thought at this point on counting up these little totals that we get along the way, the simple bits of counting. Some of you may prefer to count in your head, and that is absolutely fine. But if you are someone who prefers a more physical way of doing things, someone who needs that kind of visual or tactile input, you could draw yourself a quick number line to use. You could put 0 and 1 and 2 and 3 or whatever, just to give you a bit of a start point. How big does that need to be? I don't know. Depends what you're going to use it for. But it might be just a bit of a visual reminder as to how things work. It's also worth remembering that you've got your ruler with you. We've talked about this already. You can use your ruler as a number line. It runs from 0 to 15, or it runs from 0 to 30. And if you're starting at 7, say, and counting on 4, you can start at 7 and count 1, 2, 3, 4 on to get to 11, and so on. That would be 4 jumps. Notice we do not include the 7, because the 7 is our start point. That's 4 jumps on. 7 to 8, 8 to 9, 9 to 10, and 10 to 11. That's 4 jumps on. So 7 plus 4 is 11, and so on. Now the other tool that you've got at your disposal is these, and I happen to be a big fan of counting on your fingers. They are there, you might as well use them. Now the limit of these of course is that you can only count up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and so on. We can count in tens on our fingers. And actually most of our society is based on counting up in tens. We see tens as nice numbers. We use tens a lot. We see 0, 10, 20, 30, 40 and so on as nice numbers. The hundreds, tens and units is all based in tens. It goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and then the next column up for 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and so on. And then up to sort of 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100 for the next column up. So it's all based on this idea of 10. And that's because we in our society use what's called a base 10 counting system. It means we like tens. And that's why we only count from 1 to 10 on our fingers. And then round again, 11 to 20 and so on. But not everywhere in the world does this. Not everywhere in the world uses a base 10 counting system. Because it turns out that you can also use your fingers to count up in groups of 12. You can use your fingers to count in a base 12 counting system. And there are parts of Asia, particularly, that use base 12 as a counting system. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Base 12 counting system. We can go further than that as well, because we can also count up groups of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've counted out the first 12, so I'm going to put a finger down here. We can count out 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We've counted out a second lot of 12. So I'm going to put this one down here and we're up to 24 now. We know I've counted 12, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. I've run out of fingers, but I've counted up to 60. The ancient Babylonians used to use a base 60 counting system. It's worth bearing that in mind. That will come back later in the year. I'll mention that again somewhere else. See if you can work out where it's going to crop up. Think about things in groups of 60. Now, as well as count up to 60 on our fingers, we could also refocus and we could think about this base 12 counting system again, rather than a base 61, which is that one. We could think about the base 12 counting system, because we could count out groups of 12 on our fingers again and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. First lot of 12 covered. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Second lot of 12 covered. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Third lot of 12 covered. And I'm using the sections of my other hand to count out the lots of 12. Now, doing it this way, and counting in this kind of system, we'd get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lots of 12 covered. If we were to keep counting up, we would eventually get to 144. Does that have much bearing on anything? Well, not really, other than the fact that it's parts of Asia that use base 12 counting system, but there are certain things that are still useful to draw from that. We still see 12 as a useful number. We talk about a dozen. 12 is a dozen. And if you have 12 dozen, as in what we've just done, there is a dozen, and another one, 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 and so on. 12 dozen, 144, is called a gross. They have these important names because they are useful. So much as we do use a base 10 counting system, there are still remnants of other counting systems there in our culture, in our lives. One more base system that's worth bearing in mind. We can only count up to 10 on our fingers, so we use a base 10 system. We could, if we threw in our toes as well, use a base 20 system, 10 fingers, 10 toes. Please do not count on your toes in the exam. If you are going to do counting on your fingers, stick with 10 or maybe try 12 if you fancy. However, while a base 20 system is not that common anymore, it did used to be used in France. And if we were to look at the French number system, then we would see that. Well, if we look at the French number system, we will see that. 10 is 10, 20 is 20. If we skip a little bit and go to 80, 80 is 80, as in 4 20s. And 90 is 90, 4 20s and a 10.